I'm Geisel, and I'm starting off with a domino lab. So basically we're just stacking the dominoes, and I'm going to hit the bottom one towards the barrier. So all of them fall. Basically this demonstrates the first law of motion, that every object remains in its place except when a force is applied to it, force being my ruler. It was a sharp force, so now we're going to try out the gentle force exerted onto it. So I'm just going to lightly tap now. So I just move slightly. I'll try it again. Okay, so that took a lot more work than the first one. Okay, so now I'm doing the coin experiment. So I'm placing the piece of paper that I have so that part of the paper is on the table and part is hanging off the edge, like so. Then I'm placing one of the coins, and right now I will do the penny. And now I have to attempt to remove the paper from under the coin with the least disturbance to the coin. Okay. So know where it is right now, and it only moved very slightly. Okay, now I will test it with the nickel. Okay, see where it is? And it's harder than the penny, so I'm going to try that again. So it definitely moved much more than the penny. And now I'll try with the dime. That moved a little bit more than the penny, but a little bit less than the nickel. Let me try again. So that was pretty good. It just moved slightly more than the penny. So I believe that the second or the third Newton's law applies, the one that says exactly, for every action there's an equal and opposite reaction. So as I pulled away with my paper, went in one direction, but the coin went in the other and stayed pretty close to where it was, and it was pretty equal to my force also. Okay, pause it right now. Okay, now I'm doing the pushing a box experiment, and I have an empty box here, and I'm just going to exert a little bit of force and see how far it goes. So I didn't exert very much force, but you can see that it went a long way, and I'm just going to mark it with a piece of tape. Okay, now I'm going to add some weight to it and put in a book. Okay, so now I'm going to try to push it the same length that I pushed it the first time. Ready? Okay, so that required a little bit more force, but it still didn't go as far as it did the first time, and I'll just mark it there. Now I'm adding another book, which is a lot heavier than the first book, so it'll add a lot of extra weight, and I'm going to try to push it how far it went the first time. Ready? Okay, so that required a lot of force because I recognized that it wouldn't go very far without the force that it needed. So it did go farther than the first two, which is pretty surprising, as you can see. 1, 2, 3. So with the most weight, it went the farthest. Let's see why. Okay, so this experiment applies to the second law of Newton, that the net force on an object is equal to the mass times the acceleration. Basically, this is saying that the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to the object's mass. So as the mass is increased, the acceleration decreases, but since the net force that acted upon it, which was my push, was so much stronger because I realized that I needed to push harder to make it as far as I did, the acceleration increased because the acceleration is directly proportional to the net force.